10.4. 10.4 is over inscribed angles and polygons. Inscribed angles and polygons. So, in our last, not our last lesson, but we learned about central angles. What is a central angle? What makes it central? It's in the middle of the circle. It's okay. What part of it is on the middle of the circle? The vertex. So we learned about central angles, where the vertex is on the center. What relationship did it have with its arc? It was congruent. So whatever the angle was, the arc was as well. Today we're going to learn about inscribed angles, which do not sit on the center like a piece of pizza. They actually sit on the side. So they could look like this. They could look like this. But basically the vertex is on the side, and it creates a relationship with what we call the intercepted arc. The part that students are finding the hardest today are understanding where the intercepted arc is. So think of it like, I don't know, I see like a megaphone, I see like an upside down ice cream cone. I don't know, what do you see? If you saw a circle, that's not a good circle, come on. If you saw a circle and a V, and then the intercepted arc is between the two rays of the angle. What like do you see visually? A piece of pizza, okay. The avatar symbol?
Yeah, like a little tattoo.
Chuck E. Cheese.
Chuck E. Cheese pizza.
Yeah.
Interesting. Okay, so keep all of those in your mind, because I'm telling you right now, the part that is the hardest for my students today is seeing what the intercepted arc is. And I am having trouble with describing it in any other way besides it's where the angle starts and stops on the arc. Like I don't know how to dumb it down more.
Is it like diagonal from the vertex?
Yeah, it's opposite of the vertex, and it will be from one of the rays to the other ray. It like outlines it itself, so I'm struggling. Anyways. Side view of a kid wearing a bicycle helmet.
What? No one.
It looks like a Harlem.
He's probably like left-brained or something. I don't know. I don't see that. But if you see it, then that's great. Your first blank is about an inscribed angle. An inscribed angle is an angle whose vertex is on a circle and whose sides contain the chords of a circle. Oh, Justin. So I would highlight an inscribed angle. I'll highlight it in green. There's your vertex in yellow. And your inscribed angle. You have a picture to the right of your fill in the blank. We're on 10.4, which would help you. Yes.
Like, wow.
So now I would highlight the angle we're talking about. So the angle is what is on top of the side of the circle. The intercepted arc is an arc that lies between the two lines, rays, or segments. Okay? I don't know. I kind of see like a flashlight. Y'all ever watch like Scooby-Doo as a kid?
Yes.
Was Scooby-Doo out when you were a kid?
Looks like a thing on
If you're like holding a flashlight on Scooby-Doo, you know what I'm talking about? Like you would see this whole... Sure, it's kind of a Pac-Man. It's Pac-Man like finishing off one of the little cherries. So these are the two parts. There's actually a relationship. They're not congruent. Central angles, they're congruent. Those are easy. These are also easy. As long as you can do double and half, you'll be just fine. So from here, we're going to go to the center of the page where there is a theorem, I want to say. All right, so it appears my theorem is different than yours because we're all just hot mess, so don't fill this in. if an angle is inscribed in a triangle, then it's half the measure of its intercepted arc. Here's what I want you to write down. Write down here. The angle is half the arc. The arc is double the angle. So I want you to write down what's written in purple down here. The angle is half the arc. The arc is double the angle. The angle is half the arc. The arc is double the angle. The angle is half the arc. The arc is double the angle. Here's what that means. Pick an even, slightly largest number.
576.
Okay, Trent.
42.
First off,
You said slightly 20.
360 degrees is what a circle is, so 500 and something is ridiculous. I'm talking, what?
128. 70.
I'm talking 60.
120.
I like 64. Let's stick with 64. Let's say this arc was 64 degrees. What would the measure, now listen, what would the measure of its central angle be? The central angle, listen to my question. Central angle, we're not talking about this right now. 64. Because what do you know about central angles and their arcs? They're congruent. However, so that's a central angle, because guess where the vertex is? On the center. If I was talking about what's highlighted in red, that is an inscribed angle, because it is on the edge of the circle. So now I will ask, if the arc is 64, what is the measure of the angle? 32. Okay, we've got to listen to the questions. So the arc is double the angle is half the arc. That's the relationship we're talking about. Diane, I'm glad that made you smile. Let's do 1 and 2. Number 1, I know it says the measure of the red arc or angle. Yours isn't red, mine is. This is the angle we're talking about. What is the name of the intercepted arc? What is the name of the intercepted arc?
DGA. No.
2 letters. HF. So the name of its arc starts and ends on the edge of your angle. So that means 90 degrees is going to have a relationship with angle G. It's going to be double of angle G. So how do I find angle G? I have it. What's half of 90? 45. Because the angle is half the arc is double the angle. All right, number 2, we're finding an arc this time. What is its angle? TUV. Yeah, TUV is just 38. So we already have the angle. We double it, we find the arc. So what is double of 38? 76. All right, so the reason I'm emphasizing what the arc is going to be is this will be a difficult concept if you don't understand what the arc is in comparison to the angle. This is in the center of the page. You haven't filled it in yet. You should have a picture that looks just like this. If 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. Your blank is going to be congruent. And I'll explain it with some colors. They already have the angles highlighted. These 2 are going to be congruent, and I'll show you why. All I'm going to do is outline both of them. So I outline this one. What is the arc of this angle? Give me 2 letters. AB. Now look at the second angle. Highlighted that in blue. What is the arc of this blue angle? AB. So because they have the same arc, whatever the arc was, the angle would be half of that. Since it's going to be the same arc, these 2 angles would be congruent to each other. Okay? So these aren't meant to be like really tough problems, like number 3. It's asking for you to find what's in red. Again, yours is in black and white, but the red is right here. Okay? What is the arc of my red angle? ZW. What is the arc of angle 72? ZW. So because they have the same arc, they're going to be the same measure. So what's the measure of my red angle? 72. All right, and we flip. We're going to talk about right triangles. So, before you write anything down, I'm going to simplify it for you. All this is saying is if you have a triangle inside of a circle, that means it's a right triangle. It has to be a right triangle. And because of this, the diameter will be the hypotenuse of that right triangle. Okay, so we're going to talk about your fill in the blank, and I'll highlight the most important part in a second. So if a right triangle is inscribed in a circle, I believe your blank is, then the hypotenuse is a diameter. That could be wrong. Yeah, right. So the hypotenuse is the diameter. Conversely, if one side of an inscribed triangle is a diameter, then it is the hypotenuse. I'll highlight the most important part. Highlighted it in like a greenish color. The most important piece is that the angle opposite the diameter is going to be your right angle. Because if the diameter is your hypotenuse, the angle across from the hypotenuse is always the right angle. So I'll write down and I would highlight it. And we're going to do an example. We'll look at number 4. All right, what is the diameter of number 4? km. Is it also a side of the triangle? Yes, so that makes this the hypotenuse. So which angle is going to be the right angle? X. So what does x equal? 90. All right, then what do we know about the 3 angles in a triangle? They add up to 180. So what does y equal? 50. All right, we got one more piece of 10.4. And it's about quadrilaterals. A quadrilateral is inscribed if its opposite angles are supplementary. So you want to write if its opposite angles are supplementary. So that's what goes in the blank. What does supplementary mean? They add up to 180. So my opposite angles will add up to 180. Because that is the only way a 4-sided figure will fit inside of a circle. All right, so we're going to do our other 2. What is opposite of angle D? Sorry, on my picture up here. D and F. I asked because students struggled with this earlier. And then E and G. Okay, good. All right, so on our picture, what do we want to find first? X. Sure. So what angle is across from angle B?
82.
82. So angle D. So X plus 82 will equal 180. Subtract 82. And X equals?
98.
Yep. All right, all that's left is to find Y. What is angle A across from?
68.
Yep. So Y plus 68 equals 180. Subtract 68. Y equals? Good. We do it again. We just got to make sure we get our algebra correct. Angle S is across from? Angle U. So we're going to add them. C plus 2C minus 6 equals 180. Combine like terms. What's C plus 2C? Add 6 and 3C equals 186. I'm getting there. Divide by 3 and now it equals 62. And last, V and T, you add them up, set them equal to 180. What is 8 plus 10? 18. So x equals 10. All right, so that is 10.4. We're going to do 10.7. And then we are finished with chapter 10.
What's chapter 11?
Volume. We actually go to... No, we go to 11 next. We go to 11 and then back to 8. And then back to 11. Because of SATs and spring break, the beginning of 11 is really easy. And then you come back and do SATs. Yeah.
Wait, not next week, but the week after.
All right, so this next section is over how to graph a circle. So when you get to Algebra 2, you'll have graphing calculators. But in order to graph them correctly, you have to use the correct equation of a circle. So you guys have already known some equations of other things. What is the equation of a line? Y equals mx plus b. So you already know an equation of a line. An equation of a circle is not really similar at all. Because a circle has a center and a radius. The number 1 and number 2 things you need are a center and a radius, because that's what makes a circle a circle. So what will happen is, this isn't a box in your section, but what we're going to do is we will call the center H and K. I'll explain why in a second. When you write down this formula, your center is HK, and then R represents the radius. So the formula you want to write in your box is x minus h squared plus y minus k squared equals r squared. And I will 100% explain it in 2 seconds. All right, so what did we say H and K represented? The center. So H and K is where you'll plug in the center. And then what did we say the R represented? The radius. So we're actually going to make one up and graph one. If you're friends with people from Algebra 1, they use this website. It's called Desmos. It's a graphing calculator. This is the one my students chose earlier. But we are going to pick a center and a radius. A center and a radius. And we're going to plug it into the equation and then graph it and see what it looks like. So we're going to pick a center. I would prefer you pick decently small-ish numbers.
6.
Sure. And then let's pick a negative. 6 and negative what?
4.
2. Negative 3. Negative 8.
Negative 2.
24. Negative 5.
All right, and then pick a small-ish radius. What'd you say? 4. That's fine. Okay, so here's what you would do. All right, your formula looks like this. Squared equals the radius squared. So I do this thing called a skeleton. If you think about a skeleton, it's what forms you. You fill it in with other stuff, right? So I call this the skeleton of the equation because I'm just going to plug in my center and my radius. All you need to do is learn this, and you'll be able to find the equation of any circle. My center is 6, negative 2. So I plug in 6. What am I doing? It's supposed to be xy. Nobody caught that? It's xy like a coordinate point. Are we all okay with that? I'm sorry. I'm just making mistakes today. It is not my day. Anyways, so we're going to plug in our x with our x. We're going to plug in our y. What was our y? Negative 2. So when you plug in this negative 2, there was already a negative in the equation. So what happens? It becomes a positive. Good. I'm going to plug in my radius, which we said was 4. From here, you would simplify the best you can. Can you simplify x minus 2 any further? No. It's a number and a letter you can't. Y plus 2, can we simplify that? No. What is 4 squared simplified as? 16. 4 times 4. You said 8. It's all good. All you have to do is plug in the center and the radius, and it will be the correct equation of the circle. Okay? So that is what we're doing. You won't always graph them. I'm just showing you what you're visually doing, what the purpose is. So the number 1 and 2 things are the center and the radius. So we are going to start in the center of your page at A and B. We're going to write the equation of the circle. So we need to know the center and we need to know the radius. So let's find the center of the circle. What do we think it is? Yes, I would agree. So it's -5, 4. What I do, if I really can't see it, I find where the circle stops going down and starts going back up, and put a line there, and then I do the same thing with the side. That's your center. And then how many units away is it from the edge? 1, 2, 3, 4. So our radius is 4. And our center is -5, 4. I always write the skeleton of the equation. And then I plug in. What am I going to plug in the x spot? -5. What happens when I plug in that -5? Becomes a positive. And then my y, which is 4. And then my radius squared, so 4 squared. You want to simplify as much as possible, but the only thing that we can simplify looks to be 4 squared, which is 16. That's it. That's the equation of the circle. All right, letter B. We're doing the same thing. So the number 1 reason that students, and I don't think this will be you guys because you're honors, but the number 1 reason students will get this correct on the test is that they don't learn the formula, or the equation, really. It says the center is at the origin. What is the coordinate point of the origin? 0, 0. And then what is the radius? 3.5. All right, so we're plugging in 0, 0 for the center and 3.5 for the radius. You do need to simplify this, make it look a lot prettier. What is x minus 0? X. And then drop down the squared. And then what is y minus 0? Y squared. And then 3.5 squared. Yes, ma'am. 12.25. All right, we're going to graph it and then write the equation. So 2 things you need are center and the radius. So the center of the circle is 0, 0. So what do you think we do at 0, 0?
Put a point.
Put a point. This is where you're going to really test your drawing of a circle skill. Then you need to use the radius 2.5. So you're going to go over 2 units and a half, up 2 units and a half. So over 2.5, up 2.5, to left 2.5, and down 2.5. And then do your very, very best. Don't judge yourself, because I'm not judging you. It's not terrible. You just connect the dots at that point. And then we need to write the equation. What would the equation look like if it's 0, 0? X squared plus y squared equals 2.5 squared. What is 2.5 squared? 6.25. All right, and then the second one, our center is negative, what is it? -2.5. So over 2, up 1, 2, 3, 4, 5. You're not going to fit this on the graph. I'm sorry. But it'll be okay. So up 7, down 7, left 7, right 7. 1, 2, 3. And then connect the dots. It's not the worst I've seen. So when we plug into our formula, our center, -2 and 5, when I plug in -2, what happens? Comes up positive. I'm going to plug in 5. My radius is 7. Can I simplify x plus 2 squared? And I can't y minus 5 squared, but I can 7 squared, which is 49. Asking us to find the center and the radius. We're not going to sketch the graph. So remember that whenever we plugged into the formula, the radius was squared. Also, when we plugged into the center, whatever number we plugged in, like if we plugged in a +1 and a +4, when we plugged it in, now they looked negative, don't they? But we plugged in a positive number. So whenever you look at this for the center, they had to plug in a +1 for it to now look like a -1. They had to plug in a -3. So like if I wanted to plug in a -4 instead, if I plug in a negative and there's already a negative, that makes it turn into a positive into my equation. So the center is always going to be the reversed signs. So what is the center of number 1? 1, -3. And then my radius is 2. Distance can't be negative. It would be 2. Because this is the radius squared equals 4. You take the square root, and that's the radius. All right, number 2, the center is going to be 2, -1. And then here the radius is 4. Good.